So this is a video to look at the GCSE qualitative analysis. Qualitative analysis is essentially using chemical tests to identify various unknown compounds or elements. These tend to take the form of aqueous ionic compounds with an anion and a cation in it, or some gases as well, just the common gases that you've met at GCSE. So we'll have a look at these. Some of these you'll already know because you'll have met various ones, especially the gases at Key Stage 3. So you can see all the common gas tests on the board now. Hopefully you're able to recognize them. So maybe if you just have a look at them, and then I'll quickly tell you what they are, just to sort of check your understanding to date. So maybe pause the video, work out what they are, and then come back. So the top left-hand one is the relighting of a glowing splint. That is oxygen, of course. I'd like to think everybody got that. This one, well, fairly obviously it's chlorine. Okay, you haven't actually done that one yet. The one we have down here, this is our lit splint, and then it is popping. That, hopefully you understand, is hydrogen gas. This gas bubbling into a colourless solution, which is turning the colourless solution then milky white. That is, of course, carbon dioxide gas. And then finally you have here some gas which is turning damp red litmus paper a blue colour. That gas is ammonia. Okay, so those are some of the gases that you have to know. In actual fact, ammonia you don't have to know for GCSE, but all the others you do. So if we look at, ignore the ammonia on the left-hand side, if we look at the chlorine, so the simple test for chlorine, which is in the group 7, the halogens topic, is where you take some damp blue litmus paper. That damp blue litmus paper initially turns red, and then chlorine has the ability to bleach that damp blue litmus paper completely white. So it goes red, then it goes white. That's your test for chlorine, as opposed to other acidic gases, which will just turn damp blue litmus paper red and leave it red. Oxygen, I'd like to think you all know that. That's your relighting of your glowing splint. Very simple. Done that from your probably year 8, year 9. Hydrogen, that's your popping of your lit splint. Okay, again, a very common test that you'd have done from your year 8, year 9. Carbon dioxide, again, a very common one again, where you take in carbon dioxide, bubbling it into colourless lime water. That lime water goes sort of a milky white colour. That's because of the formation of a compound called calcium carbonate. Calcium carbonate is an insoluble compound. Okay. And that is what causes the water to look that white colour. You can see the chemistry at the bottom. This actually happens in 2 reactions. So the calcium hydroxide, that is what a solution of lime water actually is from a chemical perspective. We add our carbon dioxide to it and we get calcium carbonate. Calcium carbonate is that white substance in there. Okay, that is essentially the main ingredient of limestone. Okay, limestone rock. Now, we haven't shown it here, but if you keep bubbling and bubbling and bubbling that carbon dioxide through the solution of calcium carbonate, it will actually go back to going colourless again. And you can't see this if you do this when you're doing the experiment in class. And that's because the calcium carbonate that's made there, okay, reacts further with the carbon dioxide in the water that's in the solution. If you keep supplying carbon dioxide to it, that forms a compound called calcium hydrogen carbonate, which you can see now is aqueous, or in other words, dissolved in water. And that means that if you continue to bubble carbon dioxide through a solution of lime water after it's gone milky white, it will eventually go colourless. So those are your summaries of your tests that you guys have to know. Okay, I'll leave that up there if you want to take a photograph of it or just learn it or read it. So quick test here then about what some of these actual gases are that are being produced. So if you want to pause the video and go through them and decide which they are, then I will give you the answers. So pause the video now. So that one is the one you don't need to know, but some of you probably remember it anyway. That's ammonia. This is, of course, carbon dioxide bubbling through lime water. This is where our pH paper is going red, or litmus paper is going red, and then it's going white. So that's chlorine gas. This is our relighting of our glowing splint. So that's oxygen. And this is, of course, the popping of our lit splint, which is, of course, hydrogen. Now you also have to know a test for other things beyond gases. One of them, and you've already done this a couple of times in your year 11, where you test for water. So the test for water is that you add a colourless solution, the colourless solution that you are investigating, to what we have on the board at the minute. That's that white compound. The white compound is anhydrous copper sulfate, so make sure whenever you're answering the question you do use the term anhydrous copper sulfate. You add water to it and you make a compound between the two of hydrated copper sulfate. Hydrated copper sulfate, very simply, is this blue substance in the middle. It's a blue solid, and that presence of the blue solid within the white solid tells you that your colourless liquid that was added to the white solid was water. You get a bit of heat given off here as well, so you might see a little bit of steam, probably not very much though. Okay, let's have a look at a test for anions. So anions, as you hopefully know, are negative ions. So what you'll be asked to do very often is identify an ionic compound. And remember, an ionic compound is made up of a metal, positive ion, and a non-metal, negative ion. You will independently be asked to identify the metal ion, the cation, and the non-metal ion, the anion. Okay, piece that piece of information together and therefore identify the compound. So we're going to look at, first of all, the test for carbonate ions. So carbonate ions, very simple. If you add some acid to carbonate ions, you will get a fizzing. That fizzing is carbon dioxide gas. If you bubble the carbon dioxide gas through the lime water, you will then get a white, creamy, milky coloured solid or suspension. Okay, so that's how you test for anything that has a carbonate ion in it. Add acid. If it fizzes and the gas that's produced turns lime water milky, you originally had a carbonate. Sulfates then, you also get a white precipitate here, okay, but this time you add what we call barium chloride solution, and you must say the word solution. Don't just say barium chloride, which has got some dilute hydrochloric acid in it, okay, and if you get a white precipitate formed whenever you add that solution to your colourless solution to begin with, you can say you have sulfate ions present. The chemistry behind that is on the board now in the green box. The ionic equation is very simple. The barium ions from the barium chloride will react with the sulfate ions, okay, that you're testing for, and that will make a compound called barium sulfate. Barium sulfate is a very insoluble white substance which forms a precipitate in the test tube. Okay, we're going to have a look at tests for halide ions now. So halide ions that you would be asked to test for are chloride ions, bromide ions, or iodide ions. So if we take each of those three and we put them into a test tube, okay, so we dissolve them up in a solution first and foremost, usually a solution of dilute nitric acid. That is our number one thing, okay. So we get them as a colourless solution. And if I have chloride ions, on the left here, I get a white precipitate. If I have bromide ions, they will give me a cream precipitate, okay, and the yellow precipitate if I have iodide ions after I've added the silver nitrate. So I'm dissolving them up in a solution of deionized water. I'm adding some dilute nitric acid, and then to get my precipitates, I add a solution of dilute silver nitrate. Remember, when you're saying silver nitrate, make sure that you say solution. Don't just say silver nitrate on its own. Okay, the reason why is because silver nitrate on its own, not in solution, is a white solid. So you can't say I added a white solid to something and my observation was that I got a white solid, so it must have been silver chloride and therefore chloride ions. Okay, that just doesn't make any sense. Okay. So there's how the precipitates actually look when you do them in the lab. You can see the chloride on the left, the white. You can see the iodide a very yellow, and you can see the bromide a creamy colour. Kind of hard to tell the difference sometimes, I think, between those two. Okay, but the iodine is a very yellow, a very clear yellow when you see it in real life. So that's just a summary table of what I spoke about there, of the different carbonates. You might want to take a photograph of that now because we're going to do some tasks in this in a wee minute. So let's check your knowledge. So I'm going to give you some tests here now, okay, and you're going to tell me what test is suitable for, in this case, sulfate. So which of those three tests are used for sulfates? If you pause the video now. So it is, of course, the barium chloride one, okay, which gives you the white precipitate. Which of these tests are used for chloride ions? Again, pause the video and have a read of it. So yes, it's of course the silver nitrate with acidified nitric acid. You get a white precipitate. Carbonates this time. So carbonates, you add dilute acid and it will fizz. Okay, this time I'm going to give you some observations and you've got to decide what is the ion that is present. So in this one we have added silver ions to the solution and we've got a white precipitate. So pause the video, have a think about it. That's of course chloride ions. In this one, with fizzes with acid, so what ion would I have had in that original mixture, that original solid or solution? It's of course the carbonate ion. Here I get a yellow precipitate form whenever I add silver ions to this one. It's of course iodide ions. Here I have a cream precipitate when I add silver ions to it. Pause the video. Of course bromide ions. This time the addition of dilute nitric acid followed by barium chloride. So barium ions essentially, we get a white precipitate. Pause the video. That's of course sulfate ions. This time I form a precipitate, so sort of have a look at what color of a precipitate do you think that is with silver ions. Okay, it's of course a white precipitate, okay, and that is chloride ions. So those are all your tests for your anions. We're going to have a look at how we test now for cations, which is the positive part of an ionic compound. So we have a few different tests that we use here. Okay, so the first thing you need to be familiar with is what does the significance of colour actually tell us about the compound. So if I have a coloured compound, you can take clues from that as to what ions might be in it. So for example, if I have a white solid, okay, or it's a colourless solution, I can tell that the compound must contain a cation, which is from group 1, 2, 3, or it's maybe zinc or aluminium, or ammonium ions. Now it doesn't narrow it down massively, but it does rule out a lot of ions. Transition metal ions are of course coloured, and that rules out all of the transition metals if it's white solid or colourless solution. If it has colour, well, it could be one of the transition metals. You can see here iron 2, very pale green, copper 2, blue, nickel is a very sort of genuine normal green colour, cobalt here is that sort of pinkish colour, and we have iron 3, which is a yellow colour. And you can see here my group 1, which is my sodium salt, was a colourless solution. So those are all the colours of the various different transition metals and some of the non-metals that you have, or sorry, some of the non-transition metals that you have to know as well. So you can see for transition metals, iron 2, iron 3, copper, we have aluminium and zinc, and magnesium then, which are obviously not transition metals, but you still have to know them, and we'll look at those in a little bit more detail in a minute. So those are the colours of those particular ions, whether they be in solid or whether they be in solution. So that means that very often, especially for the transition metals, you can look at the bottle of solution or the sample of solid, and you can tell very quickly what the ion might happen to be within that compound. So let's look then at how we can identify some metal ions using what we call flame tests. So you need to know two things. You need to know how do you do a flame test, and then when the result of the flame test is known, what does that actually tell you? So the first thing you do is you take a piece of platinum wire or a piece of nichrome wire. Just simply take a wire that does not produce a colour itself when it's put into a flame, because obviously that colour would disguise the colour of for the metal ions. So we take a piece of platinum wire I've put on here, we dip it in concentrated hydrochloric acid. We do that partially to clean the metal, to clean the wire, make sure there's no debris from previous experiments on it. And we also do it because when you dip this wire into the ionic compound, you want it to make the metal chloride, because the metal chlorides give much better flame colours, essentially because they're more volatile than metal sulfates and metal nitrates. So we dip that into a hot blue Bunsen flame, okay? Make sure that no colour is produced, okay? And then you dip the clean wire back into fresh concentrated acid and then into a little bit of the actual compound that you're dealing with. You then return that just into the edge of a hot blue Bunsen flame, and that should give you a colour. And the colour will depend on whichever cation is present. So you can see here we've got the group 1 colours for lithium, sodium and potassium, and you can see that they are red, yellow and lilac. Very distinctive colours. You can see copper is another one that you have to know for GCSE, and it's a sort of a green/blue colour. Okay, so you have to write that in an exam. Don't write green, don't write blue in their own, write green/blue. That's for copper 2+ ions. Okay, and I think there's one missing there, is there? There should be a calcium one here as well, okay, which seems to have gone missing. So calcium is a brick red colour. Okay, so not sure, quite sure where it is. Anyway, it's not there. So calcium is a brick red colour. Right, so let's have a look here, guys. We're going to go through some flame tests, and I'm going to ask you, what do you think this is? So we can have a look at the ones that I have on the board from the group 1. Calcium, which is missing, is a sort of a brickish red colour, so sort of halfway between lithium and sodium there, if that makes sense. And then there's a copper. So this one here, how do you think that might be? Pause the video if you want. So that's yellow, sort of yellowy orange colour, that's our sodium. Next one, that's fairly obviously copper 2. Next one, yellow orange. It's going back to sodium again. This one, very obvious red colour, lithium. This one, the obvious pale sort of lilac, potassium. One on the left is copper 2, very distinctive, and the one on the right is that yellowy orange colour again, which is sodium. So dead simple. Hopefully you can pick out those colours. So we now have to sort of tie up both of the things that we did from our test for anions earlier and our test for cations, which we just did. So we're going to give you a flame colour on the left, and we're going to give you an anion test on the right hand side. So you can see the information. I'd suggest you pause the video, work out what the cation is, work out what the anion is, and then piece that piece of information together to work out what the compound itself is. So this is obviously sodium. This is our fizzing with acid to give and turns lime water milky. Okay, and so there's your lime water being turned milky there. Okay, so that's a carbonate. So this is a compound called sodium carbonate. Make sure you get the formula right if they ask you. Again, have a look at this one. Have a look at what the tests tell us. So we have a flame test here, which is yellowy orange, so that's sodium. And we have our we have our silver nitrate test over here, which gives us a white precipitate. Okay, and that's clearly white, so that must be chloride, so that's sodium chloride. Here we have a flame test again. We have a silver nitrate test on the right hand side. You can see the precipitate easily within the solution, but it's also very densely settled to the bottom. If you can see it on the video, hopefully you can. So have a pause the video and tell me what you think that is. So that's potassium iodide, yellow precipitate. This one. So we have the flame test, and then we have our silver nitrate, gives us our cream precipitate. I think I've given the answer away already on that one. Okay, so it's lithium bromide. Okay, here, flame test, and then we have another anion test on the right hand side. Pause the video. So that's potassium on the left, sulfate on the right, so it's potassium sulfate. So what tests could you do to prove that you had copper sulfate, and what would the results be? So I suggest you stop the video, write your answer to this, and then come back and check. So you would do a flame test, which would give you a blue-green color, and then you would do a barium solution test, barium ions in solution test, which will give you a white precipitate, and that will tell you you've copper sulfate. Right, so that is how we test for anions. That's how we test for cations using flame tests. We also have to be able to test for cations using solutions of sodium hydroxide and solutions of ammonia, and these form what we call precipitation reactions. So a precipitate or a precipitation reaction is whenever we take two aqueous solutions, and when they react, they form a compound which is insoluble. Okay, so that compound X in this instance would be called a precipitate. And we can use the colours of these precipitates. We've already done some of them earlier. In fact, this one here, for example, when we added dilute barium ions with aqueous sulfate ions, and we got a precipitate of barium sulfate, that's a precipitation reaction. But here we're going to use different colours of precipitates to tell us what possible cations we had. Here we were using precipitates to tell us what anions we had. So, very simply, what we do is we take our metal ion that we're trying to identify, and if it's a 2+1, we're going to add some sodium hydroxide, and that will react with 2 moles of sodium hydroxide, so to neutralise out the 2+ charge. So we need whatever number of negatives, okay, to neutralise out the 2+ charge. And that gives us MOH, the metal hydroxide on the right hand side, and you can see that it's MOH with a 2 if it's a group or it's a 2+ metal here, and that's the precipitate, that's the solid. So there's the various different ones that you will have to know. Okay, so you can see what we're doing here is we're adding, this is the ion, the metal ion itself, just in solution. This is whenever we add a little bit of sodium hydroxide. This is when we then add excess or lots of sodium hydroxide. And then this is what happens when we add excess ammonia to the same metal cation from the start. Okay, and these are all ones that you have to know. So copper ions, you should recognise those as blue, give us this blue precipitate, which stays as a blue precipitate in excess, but then goes to a dark blue solution with excess ammonia. We have, this is pale green, you can just about see it, very pale green. Iron 2 gives us a green precipitate with sodium hydroxide that stays as a green precipitate, and with ammonia the same thing happens, we get a green precipitate that remains. Down here we have iron 3 ions. Okay, iron 3 ions, distinctive sort of a yellow colour. We add hydroxide ions and we get this sort of yellowy brown precipitate, okay, which stays, and then the same with ammonia, yellow brown precipitate, which stays. Now we're into colourless solutions. Okay, so we need to be careful here. First one we have is zinc. Zinc gives us a precipitate, a white precipitate with sodium hydroxide, which dissolves in both excess sodium hydroxide and in excess ammonia. We have magnesium, which gives a white precipitate, and that stays in excess sodium hydroxide, and it also stays in excess ammonia. So you can tell the difference between colourless solutions of zinc ions and magnesium ions, because the zinc ions will dissolve in excess sodium hydroxide, and they will also dissolve in excess ammonia, whereas the magnesium ions won't dissolve in either. Okay, we have one M3+, so a 3+ ion that you need to know about. Okay, and that is aluminium, and you can see yet again it's colourless, so it can be confused very easily with our zinc and our magnesium from over here, but there is one way to tell the difference in it. Magnesium, or aluminium, sorry, will produce a white precipitate with a little bit of sodium hydroxide, as they all do. It will dissolve in sodium hydroxide, excess sodium hydroxide, but then of course so does zinc, as you can see on the previous page. So we can only tell now that this is either zinc or aluminium. We've ruled out magnesium because magnesium precipitate does not dissolve in excess sodium hydroxide, but the aluminium will not dissolve in excess ammonia, whereas if we go back here, the zinc does. So in order to tell the difference between zinc 2+ ions in solution and aluminium ions in solution, you have to do all of those tests, okay, to make sure that you know whether the precipitate does or does not dissolve. And that allows you to tell the difference. So these tests are also really, really sensitive. So, for example, if I was to go to here, and I'm looking for a white precipitate, okay, which then dissolves in excess with the zinc. The problem is if you add the sodium hydroxide too quickly, you can actually miss the original white precipitate, can come and go and dissolve really, really quickly. You just need to be a little bit cautious there. Okay, so that's how you tell the difference between the zinc, the magnesium 2+, and the aluminium 2+ ions. You have to do all of those various tests. So there's a sort of a summary table, okay, which you may well want to take a photograph of. We will do some exercises and this stuff later. I think that would come in handy. That's a summary table of the aluminium, the magnesium, and the zinc there, just on its own. Okay. Again, you may well want to take a photograph of that for what's coming up later. It's in our class notes anyway, as is the previous table. Now, you have an evaluation of those tests between aluminium, zinc, and magnesium with sodium hydroxide and aluminium. So I did sort of allude to this a couple of minutes ago, where I said that those tests have to be carried out extremely carefully because they are so sensitive. You've got to add that sodium hydroxide to them very slowly because, as I said a couple of minutes ago, that white precipitate that originally forms can dissolve so quickly that even with the addition of a couple of extra drops of sodium hydroxide, it can just simply be gone. So just be careful when you're doing that. Do add it drop by drop until you see that original precipitate, and don't just randomly shove in sort of a half a cubic centimetre or a cubic centimetre of it, because you may well miss the actual initial precipitate. Okay, right, so we have a few things here. We're going to look at iron 2, iron 3 and copper with dilute sodium hydroxide, and I just want you to predict what will happen in each case. So you've got to tell me, or you've got to not tell me, but you've got to work out what is the colour of the solution, just of the metal ion itself in solution before we add anything to it. And then what colour does it go when we add a few drops of sodium hydroxide, okay, down here. And then what colour does it go when you add excess sodium hydroxide. So colour of solution to begin with, observation with a few drops of sodium hydroxide, and then excess. So you might want to pause the video, do the exercise, come back and check your answers. So iron 2 is of course a pale green in solution. Okay, iron 3 is a yellowy colour and copper is a blue colour. With a few drops of sodium hydroxide, we get that sort of greeny gelatinous, which means jelly-like precipitate. We get a brown precipitate with iron 3, and we get a jelly-like or gelatinous precipitate with copper 2. With excess sodium hydroxide, all these precipitates remain, and they're all the same, exact same precipitates. They just have been shook up a little bit, which is why they look slightly different down at the bottom here, but they are the same precipitates that they are whenever we add a few drops of sodium hydroxide. Let's look at the same sort of principle, but for ammonia this time, so you know what to do this time. So you maybe want to pause the video, okay, and then have a go at it and then come back and check. So pause the video now if you want to. So colour in solution, okay, we have a pale green again, we have that browny yellow colour, and then we have that sort of bluey green for the copper 2. Okay, again with ammonia we get a gelatinous green precipitate with iron 2, gelatinous brown with iron 3, and gelatinous blue with copper 2. Excess ammonia, neither of the ions will dissolve in excess ammonia, the precipitates will remain, whereas the copper 2 ion will turn into a deep blue solution. So the precipitate dissolves to a deep blue solution. Okay, I want you to maybe pause the video then and have a go at these tasks here. Okay, you've got to just give me the colour of those transition metal ions when they're just in salts on their own. Okay, so iron 2 is pale green. Okay, so I'll just put them up. You should know them all by now. Hopefully you got those correct. Okay, flame test. We're back to flame test. We're asking you what is the metal ion or what is the colour. Okay, you should know those, hopefully. Again, we're going to go colour of transition metal ions just when they are in salts. And then down below, we've given you some colours as well, and you've got to tell me what the metal ion is. So pause the video, do them. I will then put the answers up. Okay, hopefully you're getting these all easily by now. Next one, some flame tests and some gas tests. So pause the video, do them, come back and check. Okay, so that's it, guys. I mean, if you're able to do those questions, you've got lots of past paper questions to do as well, and questions in your textbook and in your class notes. So if you do all of that, this topic, you should be pretty good at it. Okay, hope that helped, and good luck.